So following on from the previous video, we're going to work out the volume of a sphere by summing up all the cylinders. So we're going to integrate it from zero to R here. We're going to sum up all these cylinders. So when you look at this one particular cylinder here, it has a thickness associated with it, which is dx. And then when you rotate it along the y-axis, you're going to form yourself a cylinder here. Okay. So we're going to sum up all the cylinders. We're going to sum up all the cylinders. So to sum up to work out the volume of this cylinder, we need to know this this length here, the circumference all the way around here. Well, the circumference all the way around here, the circumference would be 2 pi whatever this length here is. Okay, so hang on. Let me just clear this up. So we're going to sum up from zero to R here. We're going to sum up all the cylinders. So when you look at this one particular cylinder here, hang on, you're going to get something like this. When you look at this one particular cylinder, you need to know the circumference of this cylinder here. The circumference of this cylinder is 2 pi and then whatever this radius is, So when you want to find out this x distance here, this radius distance, this x distance here, well, the x distance here, which is from here to here, the x distance here would be you using this. So rearrange this. So it would be r squared minus y squared, and then square root it. That would then give you your x. So this radius here, this distance here, this x distance here would be given by this. So it would be 2 pi r and then times this thing here, which would be r squared minus y squared. So this thing here would give you the circumference of this cylinder here, which is this bit here. So this is your circumference from here all the way around here. So now you need to know the height for the cylinder. What is the height of this cylinder? Now, what is the height of this cylinder? Hang on. What is the height of this cylinder? What is the height of this cylinder? It would be you using this. So the height would be you working out the y here. The height is the y value here, which would be r squared minus x squared square rooted. That would then give you the height of this cylinder. Well, that's this bit here. Okay, so this here is your circumference, and this here is your height, and the thickness associated with this is your dx here. Okay, don't forget this is half of a sphere. All right, so half of a sphere equals this thing here from remember, you're doing it from 0 to r. You're doing it from 0 to r here. So you've got lots of cylinders here. You've got lots of cylinders here, but if you sum up all the cylinders, it will give you half of a sphere. So it's just us trying to integrate this now. So let's tidy this up. Pi. Remember, you're integrating it with respect to x. 2 pi here is just a constant, so take it out. That will then give you this. So here you've got one block multiplying with another block here, but then you're integrating it with respect to x. You see, rewrite this in terms of x. So if you earlier it was this x squared equals r squared. Well, y squared would be r squared minus x squared. So put this thing here into this bit here. That will then give you this. See, this bit here is this bit here, and you've got a minus on the outside here. You've got a minus on the outside here. So that will then take you to here, and then tidy this up. So these two would cancel out, giving you this. And then you got squared, and then you got a square root. That will then give you this. Okay, so now it's just a matter of integrating this. Visualize this thing here as this to the power of a half. Okay, so now it's just a matter of you integrating this. So remember, when you integrate this, notice that this bit here. So when you integrate this, visualize it as this. At the moment you've got this. When you integrate it, you're looking for something that when you differentiate it, it will give you this whole thing here. So you're looking for something of this form here. When you differentiate it, it will give you this. But don't forget, you've got to times with, well, when you start with this, you've got to times with the derivative of the bubble itself. And the derivative of the bubble itself is this bit here. I'm just zooming. I'm just going through this really fast because we've done this several times already. So notice that when you differentiate this bit here, it will give you the 2x here, and this 2x here will make up this x here. All the integrations we've done so far, you've got the bubble here. When you differentiate the bubble itself, it will give you the x. If I were to ask you to integrate something to the power of 5, then you would be in trouble, because we haven't done this yet. All the integration that we've done so far is that when you differentiate the bubble itself, it gives you what's on the outside of the bubble. Yes, all the integration we've done so far is of this form here. When you differentiate this, the derivative of the bubble itself will give you the what's on the outside here. Well, anyway, integrate this. Sorry, hang on. Integrate this. So let's try and integrate this. Actually, I will continue in the next video. Okay. Yeah. So our next step is to integrate this. But I will do that in the next video.